For a long time, you have known that if you have a quadratic, then you can, and set it equal to 0, you can find its roots using the quadratic formula. Minus b plus or minus square root b squared minus 4ac over 2a. Over the last few lessons, we've been talking about higher powered or higher order polynomials. In the past, I've mentioned that there is an analogous formula for cubics that you can just plug the values into and follow the rules for and get your values for your roots, but it's quite a lot more complicated. And we're not interested, really, in solving cubics in that way. But we can do it. We can make some useful statements about the roots of a cubic. So let's say we've got a cubic, ax cubed, bx squared, cx d. That's one way to write a cubic. But we could also write a cubic using our fundamental theorem of algebra. Let's call it G, like this. That's a cubic with 3 roots. The main difference between G and F is that the coefficient of x cubed in G at the moment is equal to 1. But when we're talking about roots, it doesn't really matter what the coefficient of x cubed is, because we can just scale it and that won't change the roots. What I mean is that f of x divided by a has the same roots as just f of x. And all we're interested in, for the sake of today, is the roots. So I'm going to write f of x over a is equal to x cubed plus b over a, x squared plus c over a, x plus d, and I'm going to set that equal to that. Those two things I'm going to say are the same. So once we've got that statement, I can expand out the right-hand side, and I'll be able, by comparing coefficients, I'll be able to make some statements about the roots x1, x2, x3 compared to the coefficients a, b, c, and d. So let's keep the left-hand side the same, but written smaller so I can fit a bit more in on the right. If I expand that out, I'm going to get x cubed, and then the x squared terms will come from x times minus x3, or from x minus x2, or from x and minus x1. So, combine all those things together, I have minus, what's going to be easier? Okay, let's write this plus minus x1 minus x2 minus x3 times x squared. And we can do a similar thing for the coefficient of x. If I multiply it out, if I want to get x's, I'll have, say, this x times the two roots, x2, x3. And by doing the same on the others, on this x, will be multiplied by x1, x3. And this x will be multiplied by x1, x2. And they'll be positive, so it'll be plus x1, x2, x1, x3, x2, x3 times x. And then, lastly, the only way you're going to get no x's involved is if you multiply this term, and this term. That's going to be negative x1, x2, x3. So by comparing coefficients, I can make a statement about b over a and this. They must be equivalent. C over a and this, and d and this. So if I knew the roots of the equation x1, x2, x3, then I could work out the coefficients, because I know that b over a is equal to negative x1, negative x2, negative x3. But we usually write it like this: x1 plus x2 plus x3 is equal to minus b over a. Just multiplying everything by minus 1. Comparing the coefficients of x, we get c over a is equal to x1, x2 plus x1, x3 plus x2, x3. The sign on that one is already positive, so I don't need to do anything with that. And on the last one, we get, oh, that should be d over a. Whoops. Sorry about that. So on the last one, we get that d over a is equal to negative x1, x2, x3. Rewriting that the other way around, we get x1, x2, x3 is equal to negative d over a. So here's three statements about the roots of a cubic that can be useful. In fact, we can generalize this statement to higher order polynomials. So, I'm not going to prove that. Proof is in the textbook, if you're really interested. But if I've got a polynomial, f of x, starting at, so of order n, I've got a polynomial, order n, written like that, then we can make a statement about its roots. Just like in the cubic, over here, if you add up all its roots, it was equal to the second coefficient divided by the first. The same is true here. If I add up all the roots in an all the roots x1 to xn, it's equal to the second coefficient divided by first. Like I said, I'm not proving these. Proofs in the textbook if you want to review it. So the difference here is 1. These terms are next to each other. There's a difference of 1. And each term comprises 1 root. The next one, the next statement I can make, pairs everything up. x1, x2, x1, x3. So every possible pair you can make. And obviously, as n gets big, there gets a lot of pairs like this. So x2, x3, x2, x4, and so on, until you get to xn minus 1, xn, adding them all up, is an minus 2 over an. And then you can make a similar statement, grouping, so these are grouped in 2s, and you've got n minus 2. If you group them in 3s, there'll be even more of them, and it'd be n minus 3, until when you get to the middle, you'll have loads of them. That'll be the most pairs or groups, and then they'll start going down again. In fact, it'll be binomial. The number of terms will follow a binomial distribution. And then the very last one will just have 1, which will be x1, x2, x3, x4, so on, multiplied together times xn is the coefficient of x divided by the coefficient of x to the n. Oh, sorry, not the coefficient of x, all the way around. The constant term, the last one. The constant term divided by coefficient of x to the n. Okay, I'm going to do one example. And then you can have a go at a few. Let's say f of x is equal to 3x cubed minus 5x squared plus 6x minus 3. And I want to find the sum of the roots x1 plus x2 plus x3 would be given by minus b over a. Well, minus b over a is just 5/3. So the sum of the roots is 5/3. Pairwise, x1, x2, 6x1, x3, 6x2, x3 is equal to 6/3, which is 2. And x1, x2, x3 is equal to minus d over a, which is minus 3 over 3, which is 1. What this would allow you to do is, if you knew one of the roots, it'd be quite easy to find the other two, let's say you knew x3, quite easy to find the other two simultaneously from this equation and this equation, amongst other things. All right, before the lesson, have a go. One of the criticisms I had from my feedback is that you don't get enough questions on these videos. So my suggestion is that you have a go at the example from 31 before you come to class, and you can check them against the answers in the textbook. And they look like this. So f of x is equal to x to the 4 minus 3x cubed plus 11x squared plus 17x minus 4. And all it asks you to do is to find the sum of the zeros and the product of the zeros using the formulas that we talked about before. And there's the last three. Again, you can check them against the examples in the book. Can you find the sum of the zeros and the product of the zeros? Best of luck. Have a great day, and I will see you next week.